Hello everyone, welcome to my channel on Concept W. This is one of the DC machine question. Let's solve this question. Here it is given is four pole DC machine means number of poles equal to 4. Given it's a compound generator has an armature, series, shunt field resistance are 1 ohm, zero point 0.5 ohm and 100 ohm means array of 1 ohm, series field resistance of 0.5 ohm and shunt field resistance of 100 ohm. Generator delivers a rated power of 4 kilowatt at terminal voltage of 200 volts, allowing 1 volt per brush. They are asking to find generated EMF and flux per pole if machine is connected in short shunt connection as well as long shunt connection. Here, given, let's write down the data here. Number of poles equal to 4, armature resistance of 1 ohm and series field resistance of 0.5 ohm, shunt field resistance of 100 ohm. And it is delivering a power of 4 kilowatt. Then the terminal voltage is 200 volts along with their 1 volt per brush contact drop. We already know number of brushes equal to number of parallel paths. Here number of parallel paths is 4 because it's a lap connector winding. Number of brushes will also 4. It is delivering a rated power of 4 kilowatt means Vt into IL equal to 4 kilowatt. By that the load current is 20 amps. Let's now think about the option A, my question A, like connection short shunt compound machine. This is a short shunt compound machine giving a load current of 20 amps. Let's first initially we try to find out voltage across particular node VA. By doing some basic KVL, we get VA equal to zero point 0.5 into IL plus VT. By substituting IL and VT, we get a voltage VA of 210 volts. After finding VA, we find current through shunt field resistance. Shunt field resistance is VA by RSH. Then the shunt field current is 2.1 amps. By doing simple KCL this particular node, IA equal to ISH plus IL. By this we find armature current at 22.1 amps. By doing simple KVL here, E equal to VT plus IARA plus IL into RSE plus brush drop. This is brush drop. By substituting all the data, we get generated EMF of 236.1 volt. We need to find flux per pole if this machine is connected in short shunt compound machine. We already know EMF equal to Z by A into P by N by 60. It is lap winding A equal to P, then A and P cancel each other. By substituting Z equal to 200 and N of 750 RPM and induced EMF of 236.1 volt, what we found earlier. By substituting all these values, we get a flux per pole of 94.4 milliweber. Let's suppose instead of connecting short shunt, if we connect in long shunt connection, we need to find induced EMF and flux per pole. This is a long shunt connection. Here given a terminal voltage of 200 volts, then ISH equal to VT by RSH. This is 200 by 100. This is 2 amps. Already we know by VT into IL equal to 4000, IL equal to 20 amps. By doing simple KCL in this particular node, 2 plus 20, it becomes 22 amps. By doing simple KVL in this particular loop, we get an induced EMF of 237 volts. In order to find flux per pole, we already know induced EMF formula is Z by A into P by N by 60. It's a lap winding. Number of parallel paths equal to number of poles. By substituting all these things, we get a flux of 94.8 milliweber. If the machine is in short shunt compound machine, the induced EMF is 236.1 volt and flux is 94.4 milliweber. If it is connected in long shunt compound machine, the induced EMF is 237 volt and the flux is 94.8 millimeter. For this sort of questions, please subscribe to my channel.